Hey YouTube, welcome back. Today we start a new series. Today we will start series on system design, a crash course for beginners. It will be a long video, like 1 hour at minimum. And we will create like maybe we start with 9 or 7 systems that will um, introduce us how systems work and how should we behave in system design interviews. So today we start our first video. Today we design a notification system. So let's imagine right now you are in in a system design interview, and your interviewer asks you and tell you design a notification system. Design a notification system. Sorry. And all the time, system design interviews, they are pretty vague. So they start with vague questions like design notification system, with no else any in details information that can help you to understand the problem and establish the design scope. So our duty and our job as an interviewee is to make sure that we ask the enough questions to gather and to collect those requirements, so we know that what we are designing and we understand clearly the problem. um in systems and interviews, it's a good way to follow some specific framework to know how we can um, reach the how we can success in the systems and interview. So what I like to use is a four-step framework. First, we want to ask questions to understand the problem. We want to ask questions to understand the problem. Okay. Second, we wanna establish, propose a high-level design. Design. Third, we wanna get a deep dive into a specific component, and after that, we wanna go and do like we wanna make a wrap up. Um, no, no. Mhm. Okay. So let's just start. Let's just make this one. Make it understand the problem. What's going on with you, Google? Understand the. Okay. So let's just start here first. And in my opinion, understanding the problem, the first step is the most important step. If you got this step wrong, the interview is done for you. Like there is no hope at all. If you got this step really good, your step, your interview, your interview will be way more easier. So in order to be good on this one, in order to understand the problem, we need to ask questions. And if you want to ask a question, we want to ask first a question about how how the system work, or how the system function, how the system function. And let's just make it and after that we want to ask questions about who does which devices, let's call it, which, not who, which devices that is the system supporting. And we want to ask also about the scalability, how scalable our system is. Scala- And I guess these three questions you will ask them a lot, but let's just try to break them out, to break them in small questions. So, for example, these the three types. We want to know how the functions work. We want to know which devices it supports, and we want to know how the system function, and we want to know how the which devices the system supporting, and we want to know the scalability, how the scalable this system is. Scale. How scale? Let's call it. How scale. Okay, so let's just try to these three questions. It's quite important, but you find yourself breaking these questions into seven. So, for example, if we were talking now about system notification system, so we will think about like first we want to talk about how the system function. So I want to know what type of notification system, what types of notification, no, notification does the system support? Like, for example, SMS notification, email notification, app notification. What would the system support? What type of the notification does the system support? The second thing we want to know is it should be a real time system. So basically, when we got a notification, it should be sent right away directly to the user. After that, we could ask about what trigger the notifications. What triggers? No, T triggers triggers. No, notification. Okay. Maybe after that we could ask will users will users be able to opt out, for example, if they don't want to be naughty, if they wanna no longer wanna receive any notification. Maybe also we can say yeah, I guess these four questions are pretty good, solid in terms of how does the system work. So let's just let me grab this one and let's me put like like that. Yeah, and let's just no. Yeah, and I wanna make it quiet. And let's give it a color so it will be. So right now, by asking these questions, we know how the system works. Right now, we want to know which devices the system support, and it will be just a pretty straightforward, easy question to ask. Like we will ask it as it is right now, and we expect to get the answer directly from the interviewer. And we want to talk about the scale. The scale right now is a tricky one. The scale we could ask about how many notifications are sent to users to send each day to users. So in this one we will ask, can I take this one? So I'll say how many notification are sent each day to users. And yeah, so we have these questions, and you find yourself maybe you asking between 5 and 8 questions. So, for example, we're asking here, what types of notification does the system support? The system support push notifications, SMS messages, and email. So we have three things. We have I don't know what's going on, but like I have a big cough. I hope it's not something dangerous though. So let's start to gather requirements right now. So first we have first we support push notifications, push notification, and we support SMS messages, and we support email. Okay. And let's say, okay, the second question will be, is it a real-time system? We say, let's say that it will be a soft real-time system. Soft real-time system. So basically, we want a user to receive notification as soon as possible. However, if the system is under high workload, a slightly delay is acceptable. So we said that, okay, what triggers notifications? So notifications, let's be, can be triggered by a client application. They can also be scheduled on the server side. So like scheduled on server side, or actually can be triggered by client application, or by client application. Okay, we'll say, okay, will users be able to opt out? Like, for example, users who choose to opt out will no longer receive notifications. If I don't want to receive application notifications, I should be able to do that. So we said yes. Okay, so we said that. Which devices is the system supporting? We'll say that iOS, Android, and we will say I have a bad cough, guys. iOS and Android, and maybe we have like a desktop. And we will say how many notifications are sent each day to users. We say we have 10 million mobile notification, and we have 1 million SMS messages, and we have 5 million emails. So yeah, we have it right now. So right now we finished the first step successfully. We ask the question about how the system function. We ask the questions about which device is the system supporting, and we ask a question about how many notifications are sent each day to the users. In future videos, when we become more advanced, we will talk about how to gather the non-functional requirements also, because right now we also gathering the functional requirements, and we talk about the scalability and the devices are supported. But this will do in future videos. So we finished this step successfully. So let me put this step in. Yeah. Yup. Like that. So we finished this step. Let's continue on the second step, which will be to propose a high-level design. And I like to track everything because tracking is good. And the proposal level design will be a long one. So In this section, we will show the high-level design that supports various notifications types. We have the iOS push notifications, we have Android push notifications, and SMS messages and email. And we wanna structure it as follow. First, we wanna talk about. Let's just have this one here. We wanna talk about the different type of notifications. Oh, notifications. What's the different type of notifications? The second, let me make it like that. Second, we want to talk about contact info gathering, okay? And we will talk about the notification sending and receiving flow. And receive. Okay. So let's just start first to talk about different type of notifications. So let's just start here. So in different type of notifications, we have iOS push notifications. So it will look okay. This is too big, man. Let me get. First, we want to talk about the iOS push notifications. So let me just make this small. No, even smaller. So maybe you have a provider, and this is provide us with the notification. And this provider is. Can we make this bigger? Yeah. This provider, we will send the notification to something called EPNS, and it will send the iOS device. So here let's just start to look about this one, and let's just do it in here, and let's just say this is iOS push notification, and let's make it a little small and make it okay. So let's just talk about what's going on here. So we primarily need three components to send an iOS push notifications, as you can see. So for example, first we have the provider. So a provider builds and sends notification requests to Apple Push Notification Service, APN, Apple Push Notification Service, APNS, sorry. This is big. To construct a push notifications, the provider provide the specific data. So for example, we have, can we make this smaller and white, or maybe like that? So for example, it will be, we have like a device token, and this device token is a unique identifier used for sending the push notifications, and we have a payload. And the payload, this is like a JSON dictionary that contains a notifications payload. So for example, maybe it will be like something like that. We will have it will be APS, and for example, it will be like an object, and it will be like maybe example like alert, maybe another object. What? Another object. What's going on? Yeah, yeah. Okay, I was clicking on the wrong one. Maybe another object, and we have alert, and we have more like title, for example. Maybe like game requests or something. I don't know. It will be something like that, and or like game installed, for example. So this is how the payload will look like, and how the notification will look like. The APNS, this is a remote service provided by Apple to propagate push notifications to iOS devices. iOS device here, it's the client which receives push notifications. Right now we want to talk about the next thing, which will be, let me copy these two actually. Let me copy these two. So we will have Android push notification, and right, and it will be here, call it FCM, not DF, and here we will have the and right. So the Android adopts a similar notification flow. Instead of using the APNS, we're using a Firebase cloud messaging, and it's commonly used to send notifications to Android devices. We have SMS notifications. So we have like here SMS service. So in the SMS notifications, like for SMS messages, third-party SMS services like Twilio or Nexmo and many others are commonly used. Most of them are commercial services. Lastly, we have the email notification. And in the email notification, it will be provider, and we have like an email service. And we have here the actual email. So basically here it's although companies can set up their own email servers, many of them opt for commercial email services like SendGrid or like MailChimp, among the most popular email services, which offers a better delivery rate and data analysis. And we have it like that. Just it has the same flow. So let's just try to gather all of that, and let's say that we have. Let's create a new, like, yeah, like something like that. And can I make it? Can I play with it? Like, yeah. No, make it like that. Okay. And we have like, so we have four main providers or four main services. We have the APNS. We have FCM, Firebase, Firebase Cloud Messaging. We have the SMS service, and we have the email service. Let's just put them here all. I guess it's not the same or what? Let me know. No, okay. Okay. And these services used to send sends to like this, sends to iOS, and we send to Android, Android, and the email it's sent to email. Oh, sorry. If this will send to Android, sorry, and this will send to SMS. And let's just okay. So this is in conclusion right now how we will come up with, and I guess right now we finished the first section, which will talk about different types of notifications. And right now we want to talk about the second thing, which how to gather the info. So let me. So in terms of gathering the info, basically to send notifications, we need gather mobile device tokens, phone numbers, or email addresses to send to the users. Because if we don't have this information, to whom we will send the notifications to? So how we can do that? So for example, let's say that we have a user here, and I don't want to make it like that. How to make it thick? Yeah. So let's say we have a user, and this user will log in, like we'll just sign up through an API gateway or a load balancer. Okay, we go like an API gateway. Okay, and this user maybe it will sign up or like on app install, or like sign up or sign in. And when we sign up, we saved this sign up will go through like an API servers, and we could save the user's info into like a database, a DB. And like we could simplify database tables to store contact info, like email addresses and phone numbers are stored in like a user table, where devices token are stored in device table, and a user can have multiple devices, indicating that push notifications can be sent to all user devices. So for example, that if we had a table, it will be we have like a user tool, we have like a user ID, email, country code, phone number, and maybe the created ad. And in the user in the device table tool, we have like a device token and the user ID for each one to make to connect them with each other. So let's just put it here, and I guess we finished this step. It was quite fast one. Let's talk about the notification sending and receiving flow. And in this one, let's just put here. So let's I guess I need to copy this one. Yeah. So we will first present the initial designs, then propose some optimization. So right now we have services. Let's say that we have let's keep yeah. Okay, so let's see that we have like service, and these services sends the requests to a notification system. We have here a notification system, notification system. That make it like okay, like they send it like that. No. And yeah. and the notification system will send the requests to the servers, the providers, not the providers, the servers that will put the notifications to the users. So as you can see here, we have like let's just try to show this design. Let's describe what's going on here. So for example, we have servers services from 1 to n, and a service can be a microservice or a cron job or a distributed system that triggers notification sending events. For example, a billing service sends emails to remind customers of their due payment, or a shopping website tells customers that their package will be delivered tomorrow via SMS, for example. The second, we have the notification system. The notification system is the center piece of sending, receiving notifications, starting with something simple. Only one notification server is used to it provides APIs for services for these 4 services right now, and builds notification payloads for third-party services. Lastly, we have third-party services, and so third-party services are responsible for delivering notifications to users. While integrating with third-party services, we need to pay extra attention to extensively good extensibility means a flexible system that can be easily plugging or unplugging of a third-party service. And another important consideration is that a third-party service might be unavailable in a new in new markets or in the future. For instance, the FCM is not available in China. Thus, alternative third-party services such as GPush or PushY, etc., are used. We have the iOS, Android, SMS, email. These are users receive notifications on these devices that you can see here. And we have 3 problems with this design. First, we have a single point of failure. We have a single notification server, means that we single point of failure. If this one is full of, the full system is crashed. We have hard to scale. The notification system handles everything related to push notifications in one server. It is challenging to scale database caches and different notifications processing components independently. Lastly, we have a performance bottleneck, like processing and sending notifications can be resource insensitive. For example, constructing HTML pages and waiting for response from third-party services could take time. Handling everything in one system can result in a system overload, especially during a peak time. So let's try to continue like that. So we want to improve this one. So let's just improve the high-level design here. So first, we want to introduce in this notification system, we will make a distribute one. So it will be in notification system, it will be notification servers. So we have more than one server, and I guess there is a way to make it this and just to give it a low Z index. There is something come link info bring duplicate. I guess there's something like that, but I don't know what was it. Bring it back. Let me just delete this one and delete it, and yeah. And so right now we will have notification servers. We have 2. I could add 3, but it will not be look good. Other thing that we can have, we can introduce notification servers will connect with a cache and the DB, and we talk why. A cache, and the cache is connected with a DB. And other thing that we can do, which will be quite good, let's just take this, is to introduce a message queue. Let me copy this one, and we have like and we'll talk about why we do that. Okay, and let's just put here and make it smaller. Yeah, that's right. And we have 4 is that 1, 2, 4. And let's just put here. Can I take it like that or what? Yeah, it's easy. It's easy. It's easy. Yeah, and let's just take this one. And let's just take this one. And voila. And they will connect with each service. And however, when we get, like, for example, a notification fail, for example, the APNIs, when the notifications it fails, we could retry with the message queue. So let's just talk about what we have done here. So after enorming after these challenges in the initial design, we improved the design as flow. First, we moved the database and cache out of the notification server and more notification servers, and we add more notification servers. As you can see here, we have more notification servers and set up automatic horizontal scaling. We introduce a message queue to decouple the system components. So the best way to go through the above this system, this design currently. First, we have the services from 1 to n. They represent different services that send notifications via API provided by notification servers. We have notification servers, these ones. They provide the following functionalities. First, we provide APIs for servers to send notifications. Those APIs are only accessible internally or by verified clients to prevent spams. We have carry out basic validations to verify emails, phone numbers, etc. 3, we query the database or cache to fetch data needed to render a notification. 4th was lastly put notifications data to message queue for parallel processing. And we have the cache, and the cache it's user info, device info, maybe notification templates are cached. We have the DB stores data, it stores user's notification setting. We have the message queue, and the message queue, they remove dependency between components. Message queue are serve as buffered when high volumes of notifications are to be sent out. Each notifications type is assigned with a distinct message queue, so an outage in one third-party service will not affect other notifications types. And we will have also we will have workers. Okay, so sorry, there's something wrong here. Let's just pull this. Notifications. Okay, so there's something important for us to know, which is the message queue all the time work with workers, like, because the workers, they pull the messages from the message queue. So I should have worker here. Can I make it like smaller? Yeah. Delete this. No, delete. No, delete the full. Yeah. And copy from this one. And let's just put here. And yeah. And yep. And yeah. Okay. And let me. Okay, this 1, 2, 3, and lastly 4. and this one will be connected with the. It's important. I forgot workers. Workers, it's important. It's really important that when we find a message queue, there is workers all the time. So the workers here, the workers are list of servers that pull notifications events from message queues and send them to the corresponding third-party services. We have the third-party services, which will be, we explained and we talked about it, and we have the iOS SMS and email, and we already explained them in the initial design. Next, let us examine how every component works together to send notifications. So first, a server calls and APIs provided by notification servers to send notifications. Second, notification servers fetch metadata. Notification servers fetch the metadata such as user info, device token, and notification setting from the cache or database. Third, the notification event is sent to the corresponding queue for processing. For instance, an iOS push notifications event is sent to the iOS message queue. Fourth, the workers will pull notifications event from the message queue. Fifth, the workers send notifications to third-party services. Sixth, third-party services send notifications to user devices. And right now I guess we finished the. I guess you know what, I do not like this. Let's delete it. No, delete it. Yeah, and let's just. Yeah, I guess it's better like that. Can we take this like? No, I want to take this. Yeah, just quite a little bit, so it will be easier to read. Okay, so right now we finished the high level design, and right now we are going to the deep dive. So let me change the color and make this one in white again, and let's see. So let's start in the deep dive. We would start in the deep dive. We want to talk about three things. So we want to talk about. Let me. Can I? Yeah. Thank you. In the deep dive, I want to talk about three things. I want to talk about. First, I want to talk about the reliability because it's a quite important thing. Reliability. We want to talk about the additional components, and we want to talk about we want to update the design. Okay, so let's start first with the reliability. And the reliability, we want to talk about okay, so we must answer a few important reliability questions when designing a notification system in distributed environments. So how to prevent data loss? This is the first thing. And one of the most important requirements in notification system is that it cannot lose data. Notifications can usually be delayed or reordered but never lost. To satisfy these requirements, the notification system persists notification data in the database and implements a retry mechanism. So for example, we have let's say that we have this one. So for example, we have like the message queue here. And we have the workers that pull the messages from the message queue, and we have the APNS, for example, because we work with the iOS device. So to never lose data, we will have introduced like a database. So basically, the workers will save everything in notification log. So here, notification log, notification log. So notification log database is included, as you can see here, for data persistence. So will recipient receive a notification exactly once? This is second thing to talk about the reliability. So first we solve the problem on how to not lose data. Right now we want to talk about will the recipients or the users will receive the notification exactly once. The short answer is no. Although the notification is delivered exactly once most of the time, the distributed nature could result in duplicate notifications. And to reduce the duplications occurrences, we introduce a decouple mechanism to dedupe mechanism, sorry, to handle each failure case carefully. And the example, the logic will be pretty straightforward. So basically, when a notification event first arrives, we check if it's seen before by checking the event ID, and if it's seen before, it's discarded. Otherwise, we will send out the notification. And yeah, this was it. Right now, we want to talk about the additional components, and the additional components, which will be the additional components. We'll talk about maybe three components, or no, we will talk about a lot. No, we will talk about a lot. We will talk about like 5 components. So first, we want to talk about. Let's just make this smaller. We want to talk about the notification template. Notification template. One why it's wrong? Why it's wrong? Notification. Notification. Oh yeah. Okay. I swapped the O with the I. So first, I want to talk about the notification templates. So a large notification system sends out millions of notifications per day, and many of these notifications follow similar formats. So, for example, you are Amazon right now, and Amazon is sending an order. Order received email messages or something like that, and you find it has the same format, but we only change a specific data. For example, we change the orders being ordered, or maybe we change the user info, but there is a lot of things that are being duplicated. So notifications templates are introduced to avoid building every notifications from scratch. Notifications template is performed. It's pre-formatted notifications to create unique notifications by customizing parameters, styling, tracking links, etc. We want to have also a notification setting. In notification setting, users generally receive way too many notifications daily, and they can easily feel overwhelmed. Thus, many websites and apps give the users the fine-grained control over notification settings. So this information is stored in the information setting table with the notification field. So, for example, we have a user ID, and after that we have the specific channel, and for example like SMS, email, or something, and we have the opt-in, which will be true or false. If it's true, we can send locations. It's false, we can't. We have a rate limiting, and to avoid overwhelming users with too many notifications, we limit the numbers of notifications a user can receive. This important because receivers could turn off notifications completely if we send too often. 4, we will have like a retry mechanism. So here, when a third-party service fails to send notifications to a notification, we will be added to the message queue for retrying. If the problem persists, an alert will be sent to the developers. mechanism. Fifth, we have maybe a monitor. A monitor queued. A key metric to monitor is to total number of queued notifications. If the number is large, the notifications events are not processed fast enough by workers, and to avoid a delay in notifications delivery, more workers are needed, for example, and otherwise, yeah, this is the thing that we can do. We have the other thing that we have event tracking. And this one's quite interesting because let's just have here, like for example, let's start with the event start here. Let's say that we have like a start event. The event start, after that the event it's pending, and when the event is pending, we could wait to send, or we could get an error. And when the send also could be sent, or also could get an error as well. And the send will be it will be sent to like the client or the deliver. And maybe the client will be like a click on the notification, or maybe like it will unsubscribe, like unsubscribe. Let's call it on. Okay, by the way, don't forget to subscribe to my channel, because 95% of you guys are not subscribers to the channel, and yeah, so this has helped me a lot. So as you can see here, notification metrics such as open rate, click rate, and engagement are important in understanding customers' behaviors. Analytics service implements event tracking integration between the notification systems, and the analytics service is usually required. So as you can see here, this is the example for it. We have lastly, we could just let's just try to update the design right now. We will introduce a few things. Let's go to our designs. Where are our design? Where's the design? It was gone or what? Okay, this is the design. Okay. So let's delete the services and just make it services, and with S, and no need to have all of that. Yeah. And we said that we don't want to lose any okay, I want to delete all of that things, so we can make it quite easier for us to manage. And maybe we will take this one and just make it here, and also we can take this one and make it here. And we said that we don't want to lose any notifications, so we will save the notifications. The workers will save the notification in a notification log. Notification log. And we want to introduce notification template. And also this will be get from the workers. Oh no, it'll be there. And let's just take a row and put him here. Yeah, exactly. That's good. This is good. And we said that also we want to make like some sort of event tracking, and we want to have like, let's have an event tracking. Why it's yeah, event tracking. Let's call it. Let's create a new shape, and we will call it like analytics service and analytics service, and this one will be like quite white, and just make it short, and yeah, make it here. And this one will be like, for example, we have when we in the notification service, we will with here in the notification service. Let's just, can I put the cache like that here and the db up it, and can I put this one like that here? Yeah, and yeah, so it will be easier for us to pull the notification service here. So the notification service first, when right now the notification service, they handle a lot of things. One of them is to distribute the messages, is to do rate limiting and authentication, like rate limit as we talk about it, and also we will do authentication. And when we start to make authentication, we will be in the pending state. So we will try to send a pending process. And can I make it bigger? Yeah. It will be pending process. And after that, we will have the pending in the workers. For example, when the workers finish their sending, that means they send the actual message. So we will talk in the here. This will be sent, and when it get to the client, when it gets here to the client, let's just delete. Let's just when it gets to the client, we will have like a clicking rate. Can I just take this like that, and yeah, we will have like a clicking rate, and like it will be like a click rate, or like unsubscribe, click tracking. And yeah, so let's talk about this again. So basically here, after we updated the design, let's just talk about that. In the notification servers are encrypted with two more critical features, with which are the authentication and the rate limiting. Also, we also add a retry mechanism to handle notifications failure in the workers here. Between the whole, this is big mistake. This is big mistake. Thank God. Between the workers and the message queue, we add a retry mechanism. Furthermore, notifications templates provided a consistent and efficient notifications creating. Also, we save the notification in the notification log, so we'll never lose a notification. And also, we are monitoring and tracking systems are added for system health check and in the future. So let's just try to make the wrap up, because we finally finished. So in the wrap up, we want to talk about the notification system is indispensable because they keep us posted with important notifications. It could be a push notifications about your favorite movie in Netflix, or maybe about email about your order or receiving delivery, something like that. And in this video, we describe the design of the scalable notification system that supports multiple notifications formats. We talk about push notifications, as you can see. Let's go here. Yeah, we talk about the push notifications, SMS messages, and email. and we adapt the message queue to decouple system components. And beside the high-level design, we debug deep into more components, and optimization. We talk about the reliability, and we proposed a robust retry mechanism to minimize the failure rate. We talk about the security, and we use app key and app secrets and the tokens. The pair is used to ensure only verified clients can send notifications. We have tracking and monitor, and this is are implemented in any stage of notifications flow to capture important states. We have the respect user settings. This way users may opt out or in. And we have rate limiting. Users will appearing frequency, capping on the number of notifications. And yeah, that's it for today's video, and I hope you like my description. If you like my content, make sure to subscribe and hit the notification bell so you will never miss a video, and see you guys in future problems.